what is Cassandra? So that's what the first part of it is. Okay, so originally it was developed in Facebook, but before that there are two things which came in and which actually dictated the whole Cassandra evolution, which was the Google's Big Table, and I think Google's Big Table and GFS, the file system, was the two drivers for big data evolution from the last 4-5 years, and that's been the key thing. So Google has released two papers. So one is on the Google Big Table, and the other on the Google Distributed File System, the GFS. So those two papers, and at the same time, Amazon had released its paper, which is called the Distributed Hash Table for what they call as the Amazon Dynamo database. So these are the key drivers. So what does Amazon Dynamo do? Amazon Dynamo is nothing but a key value store. The key value store, in the sense it stores a key, and if you give a key, it will you can store a value of bytes into it. But the key difference why it is being used in Cassandra is that Amazon Dynamo is a peer-to-peer model, while when you look at Google's Big Table itself, it is more modeled towards HBase, where Google Big Table is not a peer-to-peer network. So you have the master-slave kind of a concept for Big Table. So the key challenges with having a master-slave is the overall maintenance and the management of the whole cluster. And there are pros and cons of both master-slave and peer-to-peer architecture. But the fundamental thing is, the maintainability, the single point of failure, all that becomes more and more prominent in the master-slave kind of an architecture. While if you're looking at a peer-to-peer network, that kind of fault tolerance exists, because the leader election and other things happens, and even if a node goes down, the other guys assume responsibility and move on. And this is what we will cover when we look at the architectural concepts of Cassandra in the subsequent sessions. But just wanted to introduce that, yeah, we are talking about two white papers which brought together. So what did Cassandra adopt from Google Big Table? It adopted the storage structure. How data is going to be stored is what it has adopted from Google's Big Table. So it has took the column family concepts of Google Big Table, and that is why you see a similarity between Cassandra and HBase, because HBase is purely modeled on Google's Big Table. So that's the key thing. We were talking about the two paper, one paper being Google, and what we took from there, Cassandra took from there is the data structure, the storage, the column family aspect, and that's what we will cover today. What is this column family business? Okay, and what it took from Amazon Dynamo is the peer-to-peer network or the topology. So it has combined the best of these two things to create something unique, and that's where Cassandra stands in. Okay, so that now the other thing which you need to really remember is that Cassandra is fully written in Java. If you look at other databases, NoSQL databases, HBase is fully written in Java, but MongoDB and others are not really written in Java. So any databases usually are written in C, C++ kind of a model, especially more of IO intensive interactions. But yeah, if you see in this, both Cassandra and HBase are in Java. So it makes Java APIs and other things more performance faster compared to the other APIs you might use. So yeah, you can connect with Cassandra, any other thing. You can connect with Python and other things, but yeah, the performance will get a little bit impacted, because now you have to convert from that particular language down to Java. So all interactions will still be on Java. Now, the key interactions usually happen through Thrift, and we will cover Thrift in subsequent sessions. So with that introduction, we will go ahead. So key points to remember what is Cassandra. So we'll come to what is Cassandra, but the key history is about peer-to-peer topology and column family. There are two things to take it, and pretty much it's based off of Java. Okay, so this is what we call about Cassandra. Cassandra is a non-relational, highly scalable, eventually consistent, distributed, structured column family data store. Okay, so this is how you describe Cassandra. So why did I put this one slide here was more to reflect that there are so many aspects which you need to look at when you look at Cassandra. Firstly, it is not a NoSQL data. It is not a relational database. So it's a non-relational database, which is a NoSQL database. So Cassandra is non-relational. All NoSQLs are usually highly scalable. So that's where the highly scalable has come. If you look at Cassandra, it is not immediately consistent. So it is eventually consistent. When we say eventually consistent, what it means is, let's say you have transactions which you inserted a record into a database. Now, when a system is fully consistent, if you read from any node at the same time, you will get the data which you last updated into it. But in Cassandra, there is a possibility that some of your nodes will give you the previous data. So that is where it says that it is eventually consistent. It is not fully consistent or immediately consistent. So it will get eventually consistent. So after maybe few minutes, if you query that particular node, the data would change. So the whole idea is that it will be eventually consistent and not immediately consistent. Now it is distributed. Obviously, we are talking about multiple nodes. Data is distributed in a whole structure, distributed cluster, and that's where it is distributed. We look at structured column family data store. Okay. So why it is called structured column family data store? Yeah, it is a column family, and we will talk about what is a column family based data store in a minute. So remember, these are the characteristics of Cassandra. Cassandra is non-relational, highly scalable, eventually consistent. It is distributed, and it's a structured column family. We'll come to column family in a minute. So let's go on to the next thing. I will introduce some concepts. So these are the few concepts from a deployment perspective. Okay, these are not concepts from a storage or other perspective. This is from a deployment perspective. So when you look at what is a cluster, a group of nodes where you store your data, and that's what is called as a cluster. So if you say you have only one node, it becomes a single node cluster. If you have 2-3 nodes, it becomes, so these nodes can be corresponding to a virtual machine, or it can correspond to a physical machine. But that is where you really see what is the entity on which you are going to install Cassandra. So if you are installing on a physical box, then that will become a node. But if you are installing on a virtual machine, then that will become a node. So a group of nodes becomes a cluster. Okay. What is replication? Yeah, so replication is basically the process of copying data from one node to other to ensure fault tolerance and reliability. Simple things, same replication principles. And what essentially we need to know is the replication factors. That is how many copies of the data will be stored. So that is why the replication factor is important. Now there is another concept called partitioner. Now how the data is actually stored. So if you look at what, let's say an employee of 0 to 1 million employees, and so when you say replication, it will be like 1 million employees data you are replicating in 3 cluster or 4 cluster throughout the 4 times in the cluster. So that is replication. But partitioning is 1 million, how will you store in the distributed form? So you will say 0 to 10 million, 0 to 1 million I might store in one machine, 0 to 1 million to 2 million I'll store in another machine, and so on. So you are basically partitioning the entire data set and storing it logically in different nodes. So that is what is partitioning. While replication is where you take 1 million, the 10 million and copy across all the nodes. So that's the difference. Okay, so you know now what is a cluster, what is replication, what is partitioning. Now let's look at a data center concept. And a data center is nothing but a group of nodes which forms the physical cluster. Okay, so the related nodes within the cluster, and the whole idea is like it is more like a data center has everything which you need. So you say that it needs if you have 2 or 3 clusters which you want and you want to join them, that also becomes an entire data center. So that's physically equivalent to what you have in your any data center. So that is just a concept. The idea was that in Cassandra there is an option called the replication can be rack aware. So you can decide, or data center aware. So you can say that, yeah, there is one data center in New York, the other one in Boston, and you can actually decide how your replication strategies will be defined. So there is a concept of snitch and other things which will go when we get into a little bit more advanced stage. So that's time where you will see that Cassandra is data center aware, and it can tell you how data will be replicated across or distributed across the data center. Okay, so that's the reason we need that particular concept.